Alright, so in this problem, I have m to the power of 9 is equal to 13 to the power of m. So now the first thing I'm going to do is I'm going to take the natural log on both sides. So now I have ln m to the power of 9 is equal to ln 13 to the power of m. Now if I have something in the form ln a to the power of b, I can move this exponent b to the front. So this is going to equal b times ln a. So in this case, I have 9 times ln m is equal to m times ln 13. Now, if I divide both sides by 9m, these two cancel out, and these two cancel out. So now I have ln m over 9 is equal to ln 13 over 9. Now, I'm going to take 5 something in the form e to the power of ln x. This is equal to x. So now I'm going to change this to sorry, this is actually not 9, this is m. This is supposed to be m. So now I'm going to take e to the power of ln m on both sides. Or sorry, now m here, this is the same thing as e to the power of ln m, because remember, these two cancel out. So now I have this is equal to ln 13 over 9. And now this is the same thing as ln m times 1 over e to the power of ln m, which is equal to ln 13 over 9, which is the same thing as ln m times e to the power of negative ln m, which is equal to ln 13 over 9. Now, if I take the W-Lambert function of something in the form a times e to the power of a, this is equal to a. So, what I'm going to do is I'm going to multiply both sides by -1 first, because we want a and a over here to be the same. Right now, this is negative ln m, and this is positive ln m. So if I multiply both sides by -1, I get negative ln m times e to the power of negative ln m is equal to negative ln 13 over 9. Now if I take the W-Lambert function on both sides, I get negative ln m is equal to w of negative ln 13 over 9. And now I'm going to take e to the power of both sides. So now I have e to the power of negative ln m is equal to w of negative ln 13 over 9. Now I can move this negative to the front. So now I have e to the power of ln m to the power of -1 is equal to w of negative ln 13 over 9. And now these two cancel out. So now I have 1 over m is equal to w of negative ln 13 over 9, meaning m is equal to 1 over w of negative ln 13 over 9. So this is my answer. Alright, so I have x to the power of x is equal to x to the power of 2. So, to solve this, I'm going to first divide both sides by x to the power of 2. So then these two cancel out, and now I have x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, x to the power of x over x to the power of 2, I can write that as x to the power of x minus 2. And this is equal to 1. Now, if I take the natural log, or ln, on both sides, I have ln x to the power of x minus 2 is equal to ln 1. And if you guys already know ln 1, that's equal to 0. So now I have ln x to the power of x minus 2 is equal to 0. So now this gives me or sorry, before all of that, now I can actually move this to the front, because if I have something in the form ln a to the power of b, I can move b to the front. So this is going to equal b times ln a. So if I move x minus 2 to the front, I get x minus 2 times ln x is equal to 0. So now this gives me two equations. I have x minus 2 is equal to 0, and I have ln x is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2. And for ln x equals 0, I'm going to take e to the power of both sides. So now I have e to the power of ln x is equal to e to the power of 0. E to the power of ln x is simply x, and e to the power of 0 is 1. So my two solutions are 2 and 1. Alright, so in this problem, I have a to the power of a is equal to a. So to solve this, the first thing I'm going to do is I'm going to take the ln on both sides. So now I have ln a to the power of a is equal to a. And if I have something in the form ln x to the power of y, I can move this exponent y to the front. So this can equal y times ln x. So in this case, I can move a to the front, so this is going to equal a times ln a, which is equal to a. Or sorry, which is equal to ln a, because I took ln a on both sides. Now, what I'm going to do is I'm going to subtract ln a on both sides. So now I have a times ln a minus ln a is equal to 0. And now if I factor out ln a, I get ln a times a minus 1 is equal to 0. So now this gives me two equations. I have ln a is equal to 0, and I also have a minus 1 is equal to 0. So for a minus 1 equals 0, all I have to do is add 1 on both sides, and I get a is equal to 1. Now for ln a equals 0, to get the value of this, I'm going to first take e to the power of both sides. So I get e to the power of ln a is equal to e to the power of 0. Now e and ln, these two cancel out, so now I get a is equal to e to the power of 0, which is 1. Well, I got a equals 1 again. So the actual thing, what I'm going to do, because there is another solution, is now instead of simply taking ln, I'm going to take ln of the absolute value on both sides. So now I have ln of the absolute value of a times a is equal to ln of the absolute value of a. Because remember over here, I only took the ln normally, but now this is the absolute value. So now when it comes over here, I'm not going to have ln of a normally, I'm going to have ln of the absolute value of a is equal to 0. And this means that a is going to equal 1 as well as negative 1. So these are my two solutions.